In the single-factor model, a firm's asset return is driven by two components, market risk and firm-specific risk. The model expresses asset return as R equals beta m plus square root 1 minus beta squared epsilon. Here, beta captures how sensitive the firm is to the market, while epsilon represents idiosyncratic risk unique to the firm. Because these firm-specific shocks are independent, the correlation between two firms' asset returns is simply beta multiplied by beta. A firm defaults when its asset return falls below a threshold, meaning R is less than or equal to K. A key concept in this model is conditional independence. Once we fix the market factor M, defaults across firms become independent of each other. By rearranging the equation, we get a minus beta m equals square root 1 minus beta squared epsilon. This shows that after accounting for the market, only firm-specific shocks remain uncertain. Unconditionally, asset returns follow a standard normal distribution. But conditionally, the mean shifts to beta m, and the variance reduces to 1 minus beta squared. Using this, we can calculate the conditional probability of default as P m equals phi k minus beta m square root 1 minus beta squared. This tells us that default probabilities depend on market conditions. If the market performs well, default probability decreases, and if the market weakens, default probability increases. Also, the variability of defaults reduces under conditioning, making outcomes more predictable. Finally, when looking at two firms together, we define joint default probability using a bivariate normal distribution. If firms are identical, default correlation is given by ρ equals phi k minus pi squared pi 1 minus pi. This shows that default correlation arises from shared exposure to the market factor. In fact, under identical assumptions, asset correlation simplifies to beta squared. So overall, the single-factor model links market movements directly to default risk and explains how correlation between firms emerges from common market exposure.